Let's say I had the quadratic y equals 2x minus 3 squared plus 4. Where is that quadratic? This means we're going to go right 1, 2, 3. And this means it's going to be twice as tall. And this tells me up 4. So normally, a regular quadratic, the first point is over 1, up 1. Over 1, up 1. But our quadratic is actually over 1, up 2. Over 1, up 2. It's taller. So everything on the inside deals with the x's, and it's backwards. Yes. We won't be multiplying on the inside, though, luckily. We'll only multiply on the outside. Because multiplying in the inside, it not only is it backwards, but it does some other weird stuff that's not worth it. So you won't see that today. Okay, what if I had y equals negative 1/4 x squared minus 1? Down 1, it's upside down, and it's 4 times shorter. Now, you would think that 4 times shorter would be over 4 down 1, but it doesn't work that way. You could do over 1 down 1/4, but it doesn't really work that way. What we do is over 4 down 4. So over 1, 2, 3, 4 down 1, 2, 3, 4. And it's wider. And I'm not very particular when you draw them. As long as you get them in the right place and it looks wide, that's okay. And technically shorter is the phrase. It's been smashed vertically. But the only transformations we're going to do would be left and right, up and down, taller, shorter, and then it could be upside down. Okay? So if I had this parabola, and then let's say it's 5 times taller, what's the equation? Negative 5 times x plus 2 squared plus 3. Is everybody okay with that? So in 1 through 8, we're on 249. 1 through 8, match the quadratic with its graph. That's a piece of cake. All right? 9 through 20, graph the quadratic which is given in standard form. So you're just going to do the XY translation, and then the negative will flip it upside down. Look at number 21. What does that 0.5 do to the graph in 21? Makes it twice as short. Okay, what about 18? What does that negative 3 do? 3 times taller, and both of those are negative, so they're upside down, right? 22, is it tall or is it short? Short. 17, is it tall or is it short? Tall. So it says graph the quadratic given in, and the book says standard form. As far as, somebody write it in the book. So every math class I've ever taken dealing with this calls this vertex form. I don't know where Cynthia got the idea of standard form. Standard form in every book I've ever seen is like 5x squared plus 2x minus 3. So if it's in factorable form, that's standard form. So I'm going to say standard form, even though Cynthia doesn't, but curse you, vertex form. Curse you, Cynthia. So 23 through 34, all of those are in standard form in my mind. And she calls them, she doesn't even say what they are. But let's do number 24. I just had a guess. Actually, somebody had written it in this book, so that's why. Okay, here is a quadratic in standard form, and we want to put it in vertex form. Okay, to put it in vertex form, we're going to complete the square. But we're not going to complete the square like we usually do. Usually, we move the 2 to the other side. We're not going to do that here. Okay? All we're going to do is bump the 2 out of the way. So I'm going to say x squared plus 8x. I'm going to leave a space and then put the 2 over there. Because we want everything on the right side anyway, and we're not trying to solve, we're just trying to change the form of the equation. So I just took the 2 and I scooted it over. Now, what goes in the factor? X plus 4. It's half of 8. And then x plus 4 times x plus 4 will give me x squared plus 8x plus 16. Okay. Now, I had a balance, and I added 16 pounds to one side. How do I make it balanced again? I could add 16 to the other side, but I don't want anything over there. I want it to remain y equals. So I am going to subtract 16 from the right side, and that will bring it back into balance. So this number and this number have a net change of 0. So I'm changing from standard form to vertex form. And in order to do that, I complete the square. And so completing the square, you get rid of the constant, you cut the middle term in half, and we get x plus 4 squared. But x plus 4 squared is actually x squared plus 8x plus 16. So when I created this, then I also created that, which makes my equation unbalanced. So I need to compensate by subtracting 16. So y equals x plus 4 squared minus 14. 2 minus 16 is 14. Okay, so it's obvious you forgot why we complete the square, so let me explain that to you. But right, let me show you in a second. So this right here is graphable. Where is that graph? Left 4, down 14. Okay, let me show you. Don't worry, this will all make sense. So let me graph x squared plus 8x plus 2. And then I graph x plus 4 squared plus 2. Or no, minus 14. Okay, I'm going to zoom standard, and it will graph. There is the original graph that's blue, and the red graph is right on top of it. It does make sense, because if you find the roots are going to be like x equals negative 7.8 comma negative 0.2. Right? Those two roots multiply to be 2 and add to be 8. Right? What two numbers multiply to be 2 and add to be 8? Maybe I guess it's probably not, maybe it's 0.1. But those two, when you add them, you get 8. And when you multiply them, you get 2. Okay? Now, let's review completing the square for a minute. If I had x squared plus 10x plus 25, what are the factors? X plus 5 and x plus 5. Right? What about x squared minus 14x plus 49? X minus 7 and x minus 7. Okay. X squared plus 6x plus 9. X plus 3 and x plus 3, x squared minus 2x plus 1. Now, all of these have something in common. They're all double roots, right? So every one of them bounces off the x-axis. Does that make sense? So this one bounces off at -5. This one bounces off at 7. This one has a bounce at -3. And this one has a bounce at 1. Okay? There's a pattern here. What do you notice about this and this? So 5 times 2 is 10, and 5 squared is 25. That pattern is true in every single one of those. So if I have this number, then that would be, this is -7 times 2, and this is -7 squared. So if I had x plus 4 squared, what is the polynomial? X squared plus 8x plus 16 is -14. Yeah, that works. Okay, so we call these perfect square trinomials because it's one factor times itself. So if you have a perfect square trinomial, the middle term divided by 2 squared will always be the last term. That's true every single time. Cut this in half. 6 divided by 2 is 3, and 3 squared is 9. Okay, does everybody understand that? Now, when we complete the square, let's say I had x squared minus 10x, hold on, I've got to make this work, plus 16 equals 0. Is that a perfect square trinomial? No. So we're going to force it to be a perfect square trinomial. What makes this not a perfect square trinomial? The 16 is the wrong number. So I'm going to get 16 out of the way. I'm going to move the 16 over here. X squared minus 10x, leave a space, equals -16. Okay? Well, if this is a perfect square, what goes inside there? X minus 5. But as soon as I put the 5 here, I have changed my original equation. What have I done to my original equation? I have added 25. But you don't see the 25 on the left side. But it's inside here. Right? So when I create this, as soon as I write x minus 5 squared, I have added 25 pounds to the left side. So I need to compensate by putting 25 pounds on the other side. So I add 25 there, and I get equals 9. Now I can square root. Because I have turned, the problem with x squared minus 10x plus 16 is it's not, well, I guess you could factor it if you wanted, but we're not going to. So I get x minus 5 equals plus or minus 3. So I add 5. So x equals 3 plus 5 is 8. -3 plus 5 is 2. Those are the answers. Right, that's not what we're doing today, but completing the square is just a way to turn a trinomial into a perfect square binomial. That's the step that we like. We started with an x squared, an x, and a constant, and we want to change it into x plus something raised to the second. So if I had x squared plus 6x plus 3, okay, So the goal here, Morgan, the goal here is to turn it into this. Y equals a times x minus h squared plus k. That's vertex form. Okay, I want to change it from standard form to vertex form. Well, you notice vertex form has a perfect square. So I just need to convert that top thing into a perfect square. Is it a perfect square now? No. What's wrong with it? The 3 is the wrong number. So I'm going to bump the 3 out of the way. I'm not going to move it to the other side. I'm just going to scoot it over. So x squared plus 6x, leave a space, plus 3. I've just moved this 3 out of the way. So now, what goes inside here? X plus 3 squared, but as soon as I write x plus 3 squared, there is a hidden 9, which makes the left side too heavy. So now, Morgan, quit getting her off task. So what do I do with the 9? So, Morgan, do you understand why there's a 9 there? Now, I've added 9 to that side. So to undo that, to make it balanced again, I need to subtract 9. So now this and this are opposites. So now I haven't changed anything. And this ends up being minus 6. Okay. So this is equal to that. And then this is equal to that. Well, no, when I wrote this, I used a 9 that didn't exist. Right? This number did not exist. It was never there. So if it's not there, is this true? No. That is only true if the 9 is there. So when I factored it into a perfect square, I relied on a number that didn't exist. So when I relied on that number, I created the 9. It's inside here. It's 3 squared. So to compensate, I had to undo it on the other side. Okay, so let's try another one. Is that a perfect square? Yeah. No. I got to get the 4 out of the way. So y equals x squared plus 2x, leave a space, minus 4. This is x plus 1 squared, which means there was a 1 there that I used that never existed. So I need to subtract 1 like that. Caitlin, you all right? Well, it's going to be the same. It's going to be the same process over and over and over. So x squared minus 12x plus 14. Is that a perfect square? No. So let me see if this helps, Caitlin. X squared minus 12x, leave a space, plus 14. And maybe if you don't understand this constant thing, this should help. So I want to factor into x minus something. But does x squared minus 12x factor into x minus something squared? No. Not yet. Right? If I want this to turn into that, what do I have to put right there? Nope, 36. Right? The number that goes there is going to be 12 divided by 2 and then squared. Right? So right now, this does not factor. I can't factor it. But I want it to be a perfect square trinomial. I want it to be, oh, looks like I got rid of them. But I want it to factor into x minus 6, right? But it doesn't. The only way that this can be x minus 6 is if I put a 36 right there. Now, are there two numbers that multiply to be 36 and add to be negative 12? Negative 6 and negative 6. So when I put this 36 here, now I can put x minus 6. But now it's unbalanced because I added 36 to one side. So now I subtract that 36. No. We just assumed that it was there, even though it wasn't. And once we assume it's there, we have to compensate by getting rid of it. So the only way this exists is if there's a 36 right there. Without the 36, it doesn't factor. We'll get to there in just a second. So this would be minus 22. Where is that parabola? Right 6, down 22. Okay. Okay, now it's about to get harder. So everybody watch this. Okay. Everything I've done so far, the middle term has been even. But let's do y equals x squared minus 5x. Oh, it doesn't matter, plus 8. Now, don't use decimals. Always use fractions. Fractions end up being a lot easier. So this would be x squared minus 5x blank plus 8. So what goes in here? Minus 5 over 2 squared. Now, what is 5 over 2 times 5 over 2? 25 over 4. And 2.5 you can't square in your head. At least I can't do it. So plus 25 over 4. So I'm going to subtract 25 over 4. And I'm just going to ask my calculator what it is. 8 minus 25 divided 4. And I'm going to turn the answer into a fraction. And I get plus 7/4. Push math. And then the very first thing says triangle fraction. Okay? Is everybody all right with that? Okay. There's one more step. Okay. Let's look. 3x squared minus 9x plus 11. Okay. Now, this is a little bit tricky. The idea is the same. There's just one additional step. Okay. So, the idea is the same, but there's one additional step. First off, I got to get the 11 out of the way. Okay? I'm going to move the 11 out of the way, and I need to pull a 3 out of that. You can. I'll show you how to do it. So this will be 3 times x squared minus 3x, leave a space, plus 11. Lainey, you really want to watch this, trust me.
But the 11 is not actually there.
No, the 11's there.
Oh, wait, I haven't looked at it yet.
Yeah. It's not a 9. No. So let's do this step. What's going to go in here? X minus 3 over 2. It's half of 3. Half of 3 is 3 over 2. Okay? So now this is 9 over 4. Now, does everybody understand it up to this point? Because now, here's where it gets, here's that one extra step. Hang on a second, not there. So does everybody get that? Yes? Everybody understands the 9 over 4. Now, it's not really a 9 over 4. It's 3 times 9 over 4. Right? So this is not the true weight. The true weight is 3 times larger than that, or 27 over 4. Right. So the only trick is when we pull that 3 out, the number we put in that space is not really the number it looks like because it's hiding underneath the multiplication. So I need to subtract 27 fourths. Okay? So 11 minus 27 over 4, math fraction, is 17 fourths. Now, this one is right 1.5, 3 times as tall, and 4 1/4 up. Okay? So you would state, oh, you don't even have to state it. You just had to rewrite it. Okay. So look at, so, you're not going to do 34. So, number 5, just graph it. Yeah, just, number 5, just graph it. Okay. Number 25. So 25 is negative x squared minus 10x plus 3. 25. Okay. Is there a problem with this one? There's a negative out front. So we're going to treat it as a negative 1. So I got to get the 3 out of the way, and I got to pull the negative 1 out. So y equals negative 1 times what? Or I need a bigger. So this is x squared plus 10x with the space. Okay, so negative 1 times x plus 5 squared. So what goes there? 25, but it's not. It's not a 25, it's a negative 25. So we add 25 to the other side. Well, it looks like a positive 25, right? But it's hiding underneath a negative 1. No. So that 25 is really minus 25. So we do the opposite. Okay. 27, you're good. 29 is like that. 31. 31, what are you going to do? You move over a 0, right? Okay. And then 33. Yeah. So number 33, this is the hardest problem, and I'm going to do it with you. 1/2 x squared minus 4x plus 3. So I need to move the 3 over and pull out a 3/2. And this is going to look, or sorry, pull out a 1/2. This is going to look really weird. So y equals 1/2 times something with a plus 3 over there. If I take a 1/2 out of this, I'm left with x squared. If I take a 1/2 out of that, minus 8. If I pull out a 2, then it would be negative 2. Right? So if I had negative 4 and I pulled out a negative 2, or sorry, a 2, what would be left? Negative 2. Because how many 2's are there inside of 4? 2. So what if I did the same thing? So I had a 4 and I pull out a 1/2. How many 1/2's are there inside 4? 8. So this is minus 8x something. Well, 1/2 times x minus 4. So this is, but it's not really a 16. It's actually a positive 8. So that 16 is hiding underneath a 1/2. So This number is bigger than it should be. This number is bigger than it should be. Right? So the 16 is larger than it should be. It's really an 8. So we subtract 8, and I get minus 11. Oh, sorry. How about minus 5? All right, today, 249, 1 through 33 odd. Good luck.